All right, guys, so this is running a rule for the given function, identify the domain and the range. We did this yesterday in class, however, I'm going to go ahead and finish this up. So this is our day with a sub on 9/10 of 21, and I'm just going to recap real quick. So for writing a rule for a given function, identify the domain and the range. Well, what I'm going to do is say that this is your x and this is your y. This is your input, your output, okay? And I'm looking for the rule for the function, which means I want a y equals something x and then plus or minus something. So we're going to first look for the rate of change, and then we're going to look for the start value. So my rate is going to be the change of y over the change of x. So the change of y down below, so this gives me 8, 8, 8. It's consistent. Up top it's 1, 1, and 1. It's also consistent. So any of those, you could take the change of y, which is down here, the 8, over the 1. So my rate is 8. In this line right here, we're going to put the rate. So my rate is 8. Now I'm going to look for my start value. My start value is when the x value is 0, what is the y? So if I went back 1, right? So 0 plus 1 gives me 1. What plus 8 gives me 8? That's actually going to be 0. So I know that my plus 0 here on the end. This is my start amount. And the start value is the value of y when x equals 0. All right, so the next part we said, and we did this in class as well, and I did it on purpose because we have this fraction here. It's a negative fraction. So the first thing I want you to do is I want you to take your negative fraction. I want you to put it over here and say it's negative 1/2 the x value plus 1. And I want you to plug in your domain, which is going to be -4, -2, 0, 2, and 4. Those are the x values. So really over here, we're going to write the x, y coordinate. I didn't leave this big enough. I'm sorry about that. So on each one of these, in my ordered pair to be able to graph it, this is -4 something. This is 2 something. This is, excuse me, -2 something, 0 something. Now it's 2 something and 4 something. Now my something is when I plug it in. So I'm going to say -1/2 times -4 plus 1. Well, a negative and a negative is a positive. 1/2 of 4 is 2. So 2 plus 1 is 3. So I know it's -4, 3. I'm looking at -4, 3 as my ordered pair. Then the next one I'm going to do, I'm going to put colors on it just so we can kind of keep them separate. -1/2 times -2 plus 1. Well, negative and negative makes a positive. 1/2 of 2 is 1. 1 plus 1 is 2. So my y value here is 2. So I'm going to have -2, 2, and that's how I get my ordered pair. The next one is 0. So I'm going to say, back to the color, -1/2 times 0 plus 1. Well, anything times 0 is 0. So 0 plus 1 is 1. The y value is 1. So 0, 1, and that's my ordered pair. The next step, I'm going to do is -1/2 times 2 plus 1. Well, a negative and a positive is a negative. So negative. 1/2 of 2 is 1. So -1 plus 1 is 0. And the last one, I'm going to have -1/2 times 4 plus 1. So negative and a positive is a negative. 1/2 of 4 is 2. Plus 1 gives me -1. So here's -1. Again, I've got 2, 0, 2, 0. And then I've got 4, -1, 4, -1. Now I'm going to take this information right here and plot it. So this is my x-axis and my y-axis. The first part, and when I do my xy, x is across, and then y is up or down. So start at the origin. I'm going to go -4, 3. So back 1, 2, 3, 4, up 1, 2, 3. -2, 2. 0, up 1. +2 at 0. And +4 at -1. All right, then the next part, given the information, determine if a given point is a solution to the equation. Well, I'm giving you an equation and I'm giving you the point. The point is x and y. I want you to plug them in for x and y and solve them. I think I did the first one in class with you. So I said 3 times my x value. Oops, my pen is like not wanting to cooperate. The x value of 3 minus the y value of 4 equals 7. Well, this would give me 9 minus 4 equals 7. That's false, because that would be 5. The next one, do the same thing. I'm going to say 3 times 1 minus -4 equals 7. And then the last one's going to be 3 times 5 minus -3 equals 7. So let's go ahead and solve it out. I'm going to have 3, take away negatives, a plus 4. So 3 plus 4 is 7. So this is true. So if it's true, that means it is a point on the line. Yes, this is false. So it was no. And the blue one, I'm going to plug it in. I'll get 15. Take away a negative means plus 18. And 18 does not equal 7, so this is false. So this answer would be no. Now it's asking me to find 3 other points that would work on the for a solution to number 7. Well, to find other points or other values that would work, well, I've already tried on the x value, I've already tried a 1, a 3, and a 5. Well, what happens if I would try maybe a 0, a 2, because 1, 0, 1, 2, 3, 4 maybe? I could try those numbers, or I could even try negatives, but something other than what I have. Now, when I plug it in for x, I have to solve for y. Okay, so if I plug it in for x, I'm going to say 3, let me do it right here, 3 times 0. My pen is charging, by the way. Times 0 minus y equals 7. Well, 3 times 0 is 0, so negative y equals 7. So I could actually say divide by -1, divide by -1, y is equal to -7. So I could tell you that this point, 0, -7, is on that line. Or I could have picked any arbitrary x, y's and just see if it's on the line. But I want it to be on the line. But that would be a solution. So pick an x, plug it in, solve for y. So the ordered pair would be 0, -7. Plug in a 2 and do the same thing. 3 times 2 minus y equals 7. This is 6 minus y equals 7. Take away 6, take away 6. Negative y is equal to 1. Divide by -1. Y would equal -1. So 2, -1. Again, I just picked any number for x and I plugged it in for y and I solved for x. You have to do the last one. You're on your own. The next set is 4 and then -1/2, a solution to the given equation. So this is my x value and my y value. Plug it into x and plug it into y and say yes or no. Let me know. Again, this would be 4 plus 2 times -1/2 equals 7. 4, this is going to be minus, what's half of 2 would be 1. Equals 7. And 4 minus 1 is not 7, so no. False. Okay, the bottom part here, I want to note, what do you notice and what do you wonder? So I want you to try this on your own. Like, tell me what you think. This is all about you, your opinion. You really can't go wrong. What do you notice? Answer that question. And then what do you wonder? Ask that question or answer that question as well. Next page. Comparing two different representations. Okay, so I'm going to have you compare two representations. Alina babysits her neighbor's children. The earnings are good. Oh, here's my equation right here, my function, where X represents, so X equals number of hours she worked. Y equals the amount of money she earned. I like writing that out to the side. So this is Alina. And her equation is y equals 840x. So let's do this. Alina, we know, makes how much? What's her rate of pay? $8.40 per hour. That is her rate. And now Jada earns $7 an hour mowing for her neighbor's lawns. So Jada is going to be, her rate is $7 per hour, or 7, yeah. Who makes more money after working 12 hours? Well, who has a better rate? Okay, so hopefully it would be Alina. How much more do they make? Well, go ahead and plug in 12. So Jada is going to be y equals 7x. So plug in 12 for x and solve each. So as I plug it in, it's going to be $1.40 more per hour times 12. Or you could say 8y equals 8.4 times 12. And the other one is y equals 7 times 12. Get those totals and then subtract. What is the rate of change for each of the situations and what does it mean? Well, we talked about that. How long would it take each person to earn $150? Now that the total is my y value. I want the total to be what? So that y equal 150. And then explain and show your reasoning. Claire and Han have summer jobs stuffing envelopes for 2 different companies. Claire's earnings can be seen in the table. Han earned $15 for every 300 envelopes he finished. So my rate here, this would be like X and Y. So this is my X and this is my Y. Remember how we found like an equation? And then who would make more money after stuffing $1,500? This is going to try on your own. I want to see your thinking. I'll go over it in class, but I want to see your thinking. And then this again is a try on your own. So Priya jogs at a constant speed. The relationship between her distance and time is shown on the graph. Notice that time is my independent variable, distance is my dependent variable. So depending on how long she goes, determines how far she goes. Diego takes a bike at a constant speed twice as fast as Priya. It's a graph showing the relationship between Diego's distance and time. So this is Priya's. Diego's is going to be another equation. So keep that in mind. If at 1, we're at what, 5? So twice as fast would be Diego. He should be at maybe 10, but I don't show 10. So 6, 7, 8, 9, 10. So he should be up here. And he's going to start down here at 0 because they're both starting in the same spot. So if I have at 0.6 at 3, so it should be at 6. And then you work your way down. Or write your two equations and then make a table. Your choice. And then make sure you answer the question. Then we have you pick blueberries from the farm, offer 6 pounds of blueberries for this much money. Sketch a graph of the relationship cost between the pounds of cost and pounds of blueberries. With 6 pounds of blueberries, remember your unit rate. So find the unit rate. I want the dollars per pound. Remember, that's going to be your y over your x. Try to write a, can you write a rule? And then a line contains these 2 points. Decide whether or not each of these points is also on the line. Show your reasoning. I just want to see what you're thinking on this. And challenge, this is a challenge. I want to see how well you do. So at this point, this is all I'm requiring you to do, I believe. Yep. For tomorrow, for Monday. Excuse me, for Monday. So at this point, you're going to be finished. Okay, then you're ready for Monday. Thank you guys for being so cooperative for the sub, and I will see you on Monday. Hopefully you finish your assessments to turn those in. You should all have greens for the unit 1, so I can give you guys all a grade. We will work with our unit 1 assessment rework after I've graded it all. So later next week.